Welcome to Tech Teach.
Different next protocols are there. Stop and wait ARQ protocols, and then go back and automatic repeat request, then select to repeat ARQ. So we will see one by one the noisy channels. Although the stop and wait protocol gives us an idea of how to add flow control to its predecessors, noiseless channels are non-existent. So it is saying like noiseless channels are non-existent in the sense practically there is no noiseless channel. But stop and wait protocol gives a basic idea like how we can do the flow control. So by doing modifications to this protocol, stop and wait protocol, there is a protocols that are being implemented for noisy channels. So the first one that we will be basically looking at is stop and wait ARQ. So here, first of all, it is basically for practical type of channels. So if it is practical means it is having noisy channel. There can be a possibility of noise. So if there is a noise means there is an error, then there should be an error correction technique should be there. Okay. So here the errors in stop and wait ARQ is done by keeping a copy of sent frame. So what it does is once it has sent a packet, it keeps a copy of the sent packet and retransmits when the timer expires. Okay, so some points are here. We need to note it down. The first one is like, first of all, while sending the packet, it keeps a copy of the sent frame. It keeps copy of sent frame for retransmission if necessary, basically. And also there is a timer. So because in the previous case, there was a case like if the acknowledgement is not received, the sender has to wait for infinite amount of time. So that's why there is a timer. So if the timer expires, so here basically if the packet is sent, once the packet is sent, timer is activated. So in that timer, there is a fixed time. After fixed amount of time, if the time out is there, then the same packet will be sent again. If the acknowledgement is not received and timeout has happened, then the same packet that has been kept a copy that will be sent again. So there is a timer facility. Okay. So that will be basically removing the disadvantage of the stop and wait protocol. One more point here. Stop and wait ARQ, we use sequence number to number the frame. So another advantage is here the numbering of frames are done. Numbering of frames. So in that basically removes the delayed acknowledgement receiving. So the delayed acknowledgement is received. So which packet or which frame acknowledgement it is about. So for removing that confusion, there is a numbering of frames are basically done. Even the numbering of frames and numbering of acknowledgement is done into this stop and wait ARQ. And the sequence numbering are based on the modulo 2 arithmetic. The next point is here stop and wait ARQ. In stop and wait ARQ, the acknowledgement number always announces in modulo 2 arithmetic the sequence number of the next frame expected. So here the acknowledgement numbers are also being done at the help of modulo 2 arithmetic. So here the design of the structure is basically done for the stop and wait ARQ. And then also how the algorithm is basically implemented. This part is also given here. So we will be going with one by one. So what happens? So whenever there is a frame that needs to be sent, so next frame to send is this 0. Suppose it wants to send it next frame, then it will be there will be a request first of all from the network layer. So with respect to this request from the network layer, it will be network data link layer will be getting the data from the network layer, framing it, then send the frame. So while sending the frame or while basically framing, it will be adding the sequence number to the frame. Then it will be sent one frame at a time. So here also like one frame at time it will be there. Okay, and sequence frame number and acknowledgement number will be considered here. So once the packet is the frame is sent, it will be having the acknowledgement number. This when it is sent, once it is sent, the timer is activated. As it is sent, the timer will be activated. So this is another event. So event 1, event 2, event 3 at the sender side. At the receiver side, here only one event is there. So once the send packet is as the frame is sent, timer is activated. Once it is reaching to the receiver, it will be notified by the physical layer. Then it will be the frame is received, then destopped, sent to the delivered to the network layer. Then it will be sending the acknowledgement frame, and this acknowledgement frame will be having the frame number or the acknowledgement number basically, and it is sent. Means if this is the acknowledgement number, this is 0, 0 frame number is sent, so 0 acknowledgement number is sent. So with respect to the frame number, whatever the sequence number of the frame number, the same numbering will be done for acknowledgement number. Okay, that will be received. So once it is acknowledgement is sent, it will be notified by the notification from the physical layer. So it is notified, and accordingly the data link layer will be receiving the frame and then able to accept the next one. So that should be only be done when the acknowledgement is received within the timeout time. So means this is the time at which the packet is sent. So suppose this is the timeout time. So within that, so suppose the packet is sent, okay, and it is received. After receiving, the acknowledgement is received within the timeout time. So within the timeout time, if the acknowledgement is received, then the next request will be taken by the network layer. Otherwise, it will be sending the same frame again. So if suppose this was the case, that is okay, the correct one. If the case is like the packet is sent, but this is the time, acknowledgement time, but acknowledgement came after the timeout time. If the acknowledgement came after the timeout time, then whatever it will be doing is, it will at this point the acknowledgement is not received, so this will be sending the same frame again. The same frame will be sent again. So this is the basic idea about stop and wait ARQ protocol. So its algorithm is given here. You can just go through it for basic understanding. And then at the receiver side also, the algorithm is given. The same thing is given when the packet needs to be sent, or when there is an acknowledgement received within the time of time, then the next request will be considered. Otherwise, it will be sending the same packet again. So with an example, the flow diagram is given for the stop and wait ARQ protocol. So here the first is given like this is the request that is made by the network layer. So suppose this is the frame number 0. So frame number 0 is sent. So frame number 0 is sent and it is received and it is sent to the network layer, and after that it will be sending the acknowledgement with respect to the receiver side. So this is the acknowledgement number 1 with respect to frame number 0, acknowledgement number 1. So if the acknowledgement number 1 is received, okay, so next once the acknowledgement number is 1 is received and it is received within there, once the packet is sent, the timer starts, and then before the timeout the acknowledgement is received, then the timer will be stopped and it will be able to accept the next request. So suppose the next request is for frame number 1. So frame number 1 is sent and timer will be start, and frame number 1 is sent, but it is get lost in between the path, in between the channel. It is not received by the receiver. If the receiver has not received, it will not be sending the request or acknowledgement. The acknowledgement will not be sent by the receiver. So if there is no acknowledgement is received till the timeout time, this is the timeout. If the timeout has completed and acknowledgement is not received, then the same frame will be sent again. That is resend the same frame. Once the resend the same frame, then here the acknowledgement will be received. Okay, so here the acknowledgement will be received with respect to the next frame. So here the acknowledgement number will be because there is a packet loss is there, so acknowledgement number will be like the acknowledgement number is 0. It will be sent, and here the acknowledgement is received within the time, so that is correct. So next request will be activated. So next request will be with respect to the frame number 0. So frame number is sent, but acknowledgement was sent, but it is not reaching to the sender because it get lost in between the channel. So if the acknowledgement is not received within the timeout time, then the timer will restart and it will be sending the same frame again, and then it will be receiving the acknowledgement. So once the acknowledgement is received, then timer will stop and the waiting for the next request from the network layer. So this is the basic idea about the flow diagram of stop and wait ARQ protocol. So I hope you have got the point. So here question is given. Assume that in stop and wait ARQ system, the bandwidth of the line is 1 Mbps. So bandwidth is given. Bandwidth in the sense means this is the road. What is the width of the road is like 1 MB. 1 Mbps. Okay, this is the channel basically. Channel width or channel capacity is that is 1 Mbps is the bandwidth basically called. So this is the bandwidth of the channel basically, and 1 bit takes 20 millisecond to make a round trip. So 1 bit is going and then returning back. It takes 20 millisecond. So it is going to ask like what is the bandwidth delay product. So bandwidth and delay. So because 1 bit takes 20 millisecond make a round trip means it is basically talking about the delay by 1 bit. So 1 bit is having 20 millisecond delay. So here what is the bandwidth product? So bandwidth and delay product will be the bandwidth is 1 Mbps, then delay is 20 millisecond. So 1 Mbps multiplied by 20. So 1 MB megabyte. So 1 into 10 power 6 into 20 into milli is there 10 power minus 3. That is coming out to be 20,000 bits. So this is the bandwidth delay product. Next part is if the system data frames are 1,000 bits in length. So data frame size is 1,000 bits in length. So frame size is 1,000 bits. What is the utilization percentage of the link? Utilization percentage it is talking about. So it is saying like it is able to get 20,000 bits at a time basically. Okay, so because it was 1 Mbps. Okay, so and 20 millisecond it is having, so it is basically 20,000 bits it will be able to accommodate one time. Okay, but it is saying like the frame size is 1,000 bits. So 1,000 bits are being sent, but the capacity is 20,000 bits. So what is the utilization percentage? So utilization percentage will be like 1,000 divided by 20,000 into 100. That will be giving out the percentage utilization. Okay, so that is coming out to be like 5%. So utilization percentage will be 5% for the link. So same thing is given here, the solution. Next question is, okay, so here it is saying like what is the utilization percentage of the link of the previous example if we have a protocol that can send 15 frames before stopping and worrying about the acknowledgement. It is saying like instead of 1 frames it is saying to send 15 frames, and 1 frame is of 1,000 bit length. So 15 frames means 15,000 bit length will be the total number of frames size, and the channel capacity was like 20,000 bits. So 15,000 divided by 20,000 into 100. So this will be the utilization percentage. So that is coming out to be like 75%. So here it is saying like before stopping and worrying about the acknowledgement, it is saying like whatever the frames are sent, it is received. Don't worry about the errors any. If there is some error, then this percentage will be less than the 75. So utilization percentage will be less than 75 if there is an error. or there is a chance of packet dropping or acknowledgement lost likewise, then the percentage will be dropped. Okay, so up to here we have seen the stop and wait ARQ protocol.